Hello everyone, in this video we'll talk about why to linearize a graph. For that, let's conduct an experiment between voltage across a resistive load and a current passes through it. Fast forward, that's my data points along with their error bars. If you want to learn how to plot error bars, please watch the video. The link is provided in the description below. Now, while plotting the line of best fit, you have to make sure that the line of best fit should be drawn in such a way it passes through every single error bar on the graph, right? Now, let us find out the slope of this line. What does the slope of this line represent? It is basically delta y by delta x. In this case, it is delta I by delta v, which is 1 over r, right? Perfect. That means if I find out the slope numerically, it represents 1 over r. But a student can draw a line of best fit like this and say that is also one of the line of best fit because it is touching every single error bar on my graph. A second student can draw a line of best fit like this and say that is also a perfect line of best fit because that is also touching every single error bar. Yes, they are also line of best fit only. That means the resistance value is not going to be one single slope. Instead, it is going to be a range of slope, right? It is going to be a range of slope. That means I'm going to have a maximum slope, comma, I'm going to have a minimum slope. So to find out the maximum slope and a minimum slope, what we have to do is we are going to take the extreme coordinates. I'll call it as coordinate A and coordinate B and take their error bars. Okay, I'll call it as upper error bar as up and lower error bar as down. So what we have to do is we have to join the lower error bar of the first coordinate. We have to join the lower error bar of the first coordinate with the upper error bar of the extreme coordinate. Similarly, the upper error bar of the first coordinate with the lower error bar of the end coordinate. Joining those two lines are going to give you two different lines with two different slopes. And you can, by looking at this diagram, you can understand that this line is having the maximum slope possible and this line is having a minimum slope possible. So since we have got a maximum slope and a minimum slope, I can say a range of 1 by r value, which is basically, 1 by r is the slope values. So 1 by r value is greater than or equal to the minimum slope possible and less than or equal to maximum slope possible. If I call the maximum slope as m1 and the minimum slope as m2, I can write down over here as m2 greater than or equal to, 1 by r is greater than or equal to m2 and less than or equal to m1. From that I can find out r. R would be 1 over m2 greater than or equal to r and it is less than or equal to 1 over m1. So this is the way we can find out an unknown quantity from the slope. Fine. So what else we can do from this max and min line? So if you extend this max and min line, you are going to have a y-intercept, right? You're going to have a y-intercept and you can see the origin is between this region, right? The origin is between this region of max line and min line. If your origin is between max and min line, you can say that your systematic error is 0 or insignificant systematic error you have. Clear? What if, take an example, what if your max line, min line, if you extend it and it is like this, and you can see that the origin is not between the region of max and min line, it is outside the region of max and min line. And this you can discuss in your physics IA, stating that you had a systematic error and what are the plausible reasons of systematic error and what are the methods you have to follow to minimize that. You don't need to hide them, and also you don't need to manipulate the data. Do not manipulate the data to make sure that origin is between max and min line. There could be some systematic error due to malfunctioning of instrument or due to zero error or due to any other causes. You can show the systematic error on your graph by talking about the origin is not between the max and min line, and you can also talk about the methods to minimize the systematic error. Now, let's go back to the question. The question was, why do we need to linearize the graph? Because you can only have a maximum and min line. The maximum and min line can only be possible if you have a linear graph, right? It is not possible if you have a curved graph. For example, I have a curved graph like this for, say, any variables x and y. You have a curve like this. You cannot draw a maximum and minimum line for that. I'm sorry, I repeat once again. If they have a curve like this, you cannot draw a maximum minimum line because the curve doesn't have a fixed slope. It has a slope changing at different points, right? So you cannot have a maximum minimum line. Because you do not have a maximum minimum line, what are the cons you have? Point number one, you cannot talk about the range of resistance values in my case. right? Because I found the maximum slope and minimum slope, which helped us to find out the range of resistance. Simply, the because of maximum and minimum line, we could find out the presence of systematic error in the experiment, which is not possible with the curved graphs. So what you have to do is you have to linearize the graph. To know how to linearize the graph, the video is there. The link is provided in the description below. Please go and watch that. So that's all in this video.